Hi class, this is section 4.5 triangle congruence, and this time we will be focusing on angle side angle and angle angle side. The learning target is that we will be able to determine whether triangles are congruent by the angle side angle postulate and the angle angle side theorem. So let's have a quick review from last video. Are the triangles congruent? If so, state the postulate. Here's our first example. Right now we only have two sets of corresponding sides congruent, and we know we need three pieces of information to even use one of the theorems. So the missing thing that we have that we could mark congruent is the side going across the middle. Since both triangles share the side, we could use the reflexive property to say that this side is equal to itself. Now the triangles have three sets of corresponding sides, and we can use the side, side, side postulate to say that they are congruent. Alright, the next one. Here we only have two sides marked congruent, and we know that this side and this side are going to be parallel. So we need to fill in some missing information before we can decide whether or not these are congruent. Using the fact that these sides are parallel, we can fill in our alternate interior angles are congruent. We can also use the reflexive property to say that that side is equal to itself. So on the left-hand side triangle, we have side, side angle, and on the right-hand side triangle, we have side, side angle. Even though these both have side, side angle, that's not a theorem or postulate that we can use to prove triangles congruent, so this one's going to be no. So let's start learning about theorems that we can use to prove the triangles are congruent. Over here in triangle BAC, we have angle B is congruent to angle X, BC is congruent to XZ, and C is congruent to Z. If two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the triangles are congruent. This is using the angle side angle postulate. We are going to abbreviate it as ASA. So BC and XZ are the included side that they're talking about in this definition. Now we're going to make a congruence statement. We're going to say that triangle BAC is congruent to triangle XYZ by using the angle side angle postulate. Looking at these three pictures below, I want you to name two triangles that are congruent by angle side angle. So if we wanted to compare the first two, we would not have angle side angle because the middle triangle only has a side, an angle, and a side. Therefore, we would look at the yellow triangle and the green triangle. So triangle ABC is congruent to triangle HGI by angle side angle. Angle B is congruent to angle G. BA is congruent to GH. AC is congruent to HI. C is congruent to I. And BC is congruent to GI. To specifically see the angle side and angle, it would be B is congruent to G, BC is congruent to GI, and C is congruent to I. The angle, then the included side, and then the angle. Could we say that any of the triangles are congruent by side, side, side? Again, you can see the first triangle and the third triangle have three corresponding sides congruent, so we could say that triangle ABC is congruent to triangle HGI by side, side, side. What about by side, angle, side? Well, if we look at the purple triangle, it has a side, an angle, and a side. Over here we have a congruent side, angle, side to this triangle. And over here we have a congruent side, angle, side. Just make sure that the tick marks are matching up to the other triangles. So each of them have three tick marks on one side. Then they have an angle with one mark, and then they have two tick marks on the other side. So actually all three triangles could be proved congruent by side, angle, side. Here we have two triangles, and we have an angle congruent, and a side congruent. If two angles and a non-included side of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. So remember that an included side has to be between two angles, so the non-included side couldn't fall between those two angles. So notice that AC is not between B and C, and ZY is not between Z and X. This is using the angle-angle side theorem. So using the angle-angle side theorem, we could say that triangle BAC is congruent to triangle XYZ using angle-angle side. Are the pairs of triangles congruent? By which postulate or theorem? A matches up with D, C matches up with E, and BC matches up with FE. We have angles, angles, sides. So these are congruent by angle-angle side. Next one. Right now we only have one piece of information marked, but we're given that MN is parallel to LK and LN is parallel to JK. So we're going to have to use those parallel line theorems that you thought were going to go away to show that different angles are going to be congruent. So I want you to try this one on your own and see if you can see what angles are congruent. So the first thing that I'm going to mark congruent is that angle M is congruent to angle KLJ. So these angles right here are corresponding angles. They are both on the bottoms of these parallel sides and on the same side of the transversal. The second pair of angles that we can show are congruent are right here. So these are also corresponding angles because they're on the tops of the parallel lines and they're on the same side of the transversal. So now we have an angle, a side, and an angle, a side, and an angle. So these two triangles are congruent by angle, side, angle. And here's the last one. We know that right angles are congruent, so those two angles are congruent. Then we have A and Y marked congruent, and then AC and YZ are marked congruent. So these two triangles are congruent by AAS. One more. This one does not have any information marked, so we are going to have to use everything we know to see if these triangles are congruent. First, I'm going to mark that my alternate interior angles are congruent. So these are two parallel lines. Here's my transversal. I'm also going to use the reflexive property to show that this QT is congruent to itself. Is there anything else that I can mark? The answer is no. So since I only have two pieces of information, I cannot show that these triangles are congruent. Write a congruent statement for the triangles and name the postulate or theorem that justifies your answer. Well, right now, looking at these two triangles, I only have one piece of information marked. So let's mark some more information. Using my parallel lines, I know the alternate interior angles are congruent. So here's a parallel line, FL, and ZQ is a parallel line. My transversal is FQ. These are our alternate interior angles because they're on opposite sides of the transversal and on the inside of the parallel lines. I also can mark my vertical angles congruent. So using this, I know I have angle, side, angle, and I have angle, side, angle. Be careful whenever you write your congruent statement that you're matching up all the congruent parts. So triangle LFO is congruent to triangle ZQO. Notice that L matches up with Z, F matches up with Q, and O matches up with O. This is using angle, side, angle. We could also mark our other alternate interior angles congruent. LZ is the transversal, and again, these two lines are parallel. If we were to mark our other alternate interior angles congruent, we could again say that these two triangles are congruent. And this time we could use a different theorem. Do you guys see how we have an angle, angle, side? Or you could go this way and say angle, angle, side. The same thing happens over here, angle, angle, side, and angle, angle, side. So we can use angle, angle, side to prove that those triangles are congruent. A lot of the problems that we'll come across in this chapter can be proved in different ways. What else do you need to know to prove the triangles are congruent by angle, side, angle? Well, right now, we only have an angle. So that means we need another side and angle to be congruent. So we could either say that VW is congruent to UX, and then say that W is congruent to X. Or you could say that VG is congruent to UR, and that G is congruent to R. This is asking us what else we need to know. Well, we need to know another side and angle that are congruent. So like I said, we could say that VG is congruent to UR and G is congruent to R. Or we can say that VW is congruent to UX and that W is congruent to X. What about if I wanted to prove these triangles congruent by angle, angle, side? Well, I need another angle and a side. So we could say that angle W is congruent to angle X, and then side WG is congruent to side XR. Or we could go the other way and say that angle G is congruent to angle R, and that GW is congruent to RX. So there's both of the ones that I just said. So let's see if you understand what we're doing. Are the triangles congruent? If yes, state the theorem. So in this triangle, we only have two pieces of information right now. We have that these angles are congruent and that these angles are congruent. Our third piece of information is going to be that middle side is congruent to itself. So on the bottom triangle, we have angle, side, angle, and on the top triangle, we have angle, angle, side. Since we have two different theorems going on, we cannot say that these triangles are congruent. Let's look at the next one. We know that these angles are congruent, and we know this is a right angle. If this is a right angle, then the other angle next to it is also right, because they're forming a line, which means they're supplementary. So that's two pieces of information that I have that are congruent in both triangles. The third piece of information is going to be that middle side is congruent to itself. So on the left we have side, angle, side, and on the right we have, on the left we have angle, side, angle, and on the right we have angle, side, angle. Therefore, we can prove that these two triangles are congruent by angle, side, angle. And then the last one. All we have is that these parallel lines are congruent. So let's start marking some other angles congruent. We know that our vertical angles are congruent, and we can use those parallel lines to show that a pair of alternate interior angles are congruent. So on the left-hand side, I have an angle, angle, and a side. And on the right-hand side, I have an angle, and a side. So these two triangles can be called congruent by angle, angle, side. That's the end of our PowerPoint. Please be sure to fill out your WSQ.